YouTube channel. I'm your host, Teacher Jonathan Miso, and we are continuing from, KCPE 2014, where we left, that is number 6. Let's read number 6.
Triangle X, Y, Z shown below has been drawn accurately. What is the measure of angle X, Y?
What is the measure of angle?
ZXY.
So the first thing is to identify angle ZXY. Don't rush just to measure, right? Mm-hmm. Who can tell us which is ZXY? ZXY. It is angle what?
X.
Remember, ZXY is like this. ZXY, the center one here. This is the angle we are measuring. Angle X here. This is the one we are measuring. That is the angle we are measuring. So again, we have identified the angle. We don't just even take our protractor now. Again, we make another judgment. What type of angle are you about to measure? I write the types of angles that we know. There is acute, which is the smallest. There is what? Obtuse. There is right. And then there is reflex. No, reflex angle. Reflex what? Angle. The right comes before the reflex, before the obtuse. If we arrange them from the sizes, isn't it? Acute is less than 90 degrees. Right is exactly what? 90 degrees. Obtuse is what? More than 180, but less than 360. Reflex is more than 180, less than 3. Is more than 180. It's more than what? 180. And this is obtuse is more than 90 and less than 180 degrees. 180 what? Degrees. Remember, a straight line like this. A straight line has got how many degrees? 180. Right? So an acute angle will be less than 90. We know 90 is supposed to be here, isn't it? This is an acute, right? Yes. Up to here, up to less than 90, up to 89, that's an acute. Then from 90, that's a right. From 90, which is more than 90, like this one, which has passed 90, but it's less than this 180, it's called what? Obtuse. Right? Yes. When it reaches 180, which is a straight line, and goes beyond 180, all this, beyond 180, we call it what? We call it what? If it's more than 180, we call it what? Reflex angle. We call it a reflex what? So before you take your protractor in when you're doing KCPE, first is to identify the angle we have identified. This one, isn't it? Yes. Then you identify the type of angle you are measuring. So what am I measuring? Just looking at with your eyes, what kind of angle is this? Acute. This is a what? Acute. It is less than 90. It is less than what? 90. Are we together there?
Yes.
So obviously this is wrong and this is wrong. Look at how you are increasing your chances of getting that question. Because you have already eliminated 2 answers which are already wrong, right?
Yes.
Hello?
Hello.
If I am to measure this angle, what type of angle is this? A what? Obtuse. What do I expect the answer to be? More than 90, but less than 180. Any answer which is less than 90, I cancel it out immediately, isn't it?
Yes.
If I am to measure this angle, what do I expect my answer to be?
More.
If I tell you reflex angle BAC, reflex BAC, a reflex BAC, what do I do? Reflex BAC. What kind of angle is this?
Reflex.
It is more than what?
180.
So I will get this angle here, which is acute, subtract from 360 to get the reflex. To get the what?
The reflex.
Back to our question. We are measuring an acute. So the answer lies here or here. We have already cancelled this because these are not acute answers. Are we together?
Yes.
So now to measure, there are 2 ways. One way is to place your protractor like this. The way I'm placing it here. Can you see the way I'm placing it?
Yes.
When you place it like that, remember, this is your baseline. What is this?
Baseline.
So when I'm using this baseline, I'm going to start with 0. To start with what?
0.
Inner scale. There are two scales. There is the outer and there is the inner. This is 170, 180. I can't start without scale. I'm starting with the inner scale. And number will start growing from 0. Then I go to 10 using the inner scale, right?
Yes.
20, 30, 40. Can you see 48 is?
Yes.
Then some 2 more degrees, 41, 42. I get what? 42 degrees. 42 what? Degrees. I want you to look at this answer we cancelled here. What answer was here?
138.
Do you know why they put it there?
Yes.
Who knows why? If you don't mind about the scale, if you don't mind about the what?
Yes,
The
scale.
scale. Then you place your protractor like this. Your candidate who is careless, you don't look about scale, you just place it like this. You'll start counting 130, 135, 136, 137, 138. Then you put this answer. That's how tricky examiners are. Can you see that?
Okay.
So what have we said? Identify the angle. Check the type of angle you are measuring. Are we together?
Yes.
Eliminate very wrong answers. And then finally, when you place your protractor, identify the scale you are using. Identify the what?
The scale you are using.
Are we together?
Yes.
I say there are 2 ways. We have got 1 way. Let's place it like that. We can also place it like that. We shall get exactly the same answer. Now this time, which scale am I using? This is my baseline. Am I using the inner or the outer scale?
The outer
The
scale.
outer, the one which starts with the 0, because this is my baseline. This is my what?
Baseline.
I count 0, 10, 20, 30. I've not placed it properly. Yeah. 10, 20, 30, 40, 41, 42. Are we together?
Yes.
Yes. But a careless person who will not do that will fail that question, right? I want somebody to measure angle Y for me. Angle Y. Before you measure, tell us what we need to know.
This is the angle Y. Now you're going to measure this one.
Mm-hmm. Yes. What type of angle is it?
Right angle triangle.
This is a right angle. This is a right angle. What type of angle is this? Is it acute, right, obtuse, or reflex? That's what I'm asking.
Right angle.
Some of you are saying like it's a right angle. It can be what? Obtuse. It lies between right and obtuse. And slightly, let's measure to see what it is.
You're going to place your protractor here.
Exactly. Now let's look at this. When you place your protractor here, the way she has placed it, don't remove it. This is your baseline, isn't it?
Yes.
The other line is here. How will you measure now? And this is the baseline. What will you measure here now? Turn your protractor. It can't be that way. Yes. It can be yes. Turn it properly. Good. This is the baseline. Now you're using that as the baseline.
Now you're going
No. Place it properly. Till we can see this line. We want to see it. We want to see it. Pandisha juu tuione na hii point ishike hii point. Yes. Na hii line imatch na hii line vizuri. So which line are we using? Which is our baseline? Si ndio hii tumeangalia tukimatch vizuri? This is our baseline. Stand in a way that we can see what you're doing. Yeah, this is the wekelea vizuri. This is the baseline, isn't it?
Yes.
So which scale are we using? Which scale are we using? Shika vitu in a way that you are able to explain, you are able to show us what you are doing, not kuweka mikono yote hapo. Wekelea vizuri ishike hiyo point. So which scale are we using? Which scale are we using? Is it the inner or the outer?
The outer.
Chini kidogo. Is it the inner or the outer?
The
outer
outer.
scale, where the 0 is outside. Where the 0 is outside.
Outside.
So a number will grow from 0, 0, 10, 20, 30, 40, 50, 60, 70, 80. You are moving. Place your protractor properly. 10, 20, 30, mind what you're doing, 40, 50, 60, 70, 80, 90, 100, 105. 100 and what? 5. So it was an obtuse angle. It was an obtuse what? Angle. So we can also place it like this, right? This to become now our baseline. So which will be the scale we are using? The inner scale. We grow from 0. We never start an angle measuring from 180. Are we together?
Yes.
We always start from 0. We go what? 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 105. So whether you place it that way or you place it that way, you get the same answer. Only what you have to be careful is the scale you are using. Like this one, we're using the outer scale. Here we're using the inner scale. So, if I place it here to measure angle Z, which scale will I use here? This is the baseline. So which scale? Outer. So I'll grow up to 28 there. If I turn it like this, which scale am I using to measure? This, the inner scale. The inner what?
Scale.
So a scale starts from 0. Have you understood that one?
Yes.
Yeah. So if you measure carelessly, you are going to get the wrong scale answer, which is 138. So if the right answer is 42, the wrong scale answer will be the supplement of it, 138. If the right answer is this, the wrong answer, which just comes straight into your eyes, is the wrong scale answer. And this is what most candidates pick. So, number 7. Number 7.
The following are prime factors of 3 numbers. What is the LCM of the 3 numbers?
Yes, these are prime factors learned in class 7. Learned in what?
Class 7.
So we have, what does that mean?
2 squared times 3 squared.
What does this mean?
2 cubed times 5.
What does this mean? 2 4. Yes, 2 4. 2 power 4. Can you say 2 power 4?
2 power 4
Times 3 squared.
times 3 squared.
When you join high school, you'll not be calling them squared and cubed. You'll be saying 2 power 2 times 3 power 2. Are we together?
Yes.
It will be sweet, eh? Yes. Let's go. Let's start practicing. We are in high school. Let's go.
2 power 2 times 3 power 2.
Again.
2 power 2 times 3 power 2.
So 2.
2 power 3 times 5. 2 power 4 times 3 power 2.
So let's analyze this. What is 2 power 2 or 2 squared? It means 2 times itself. This is Amwikali times Amwikali. Are we together?
Yes.
Then times 3 times 3. And Nesta times a what?
Unless
Don't make a mistake and say it is 3 times 2. No. It is the number times itself. Right?
Yes.
Yes. So here we get 4 times 9, which is what? 36. Are we together?
Yes.
2 power 3 means what? 2 times 2 times 2. AD times AD times AD. Mara tatu. So.
Yes.
Not 2 times 3. Don't confuse, right?
Yes.
Yes. Then we multiply by 5. 2 times 2 is
4
times 2
8
times 4, 5,
40.
40. Then 2 power 4 is 2 times 2 times 2 times 2. Kafugo, twende.
Kafugo times Kafugo times Kafugo times Kafugo.
That is 2 power 4. Are we together?
Yes.
Not 2 times 4. Are we together?
Yes.
Then we get what? 2 times 2 is 4 times 2, 8. 8 times 2, 16. Then 16 times 3 times 3. Sawa? Which is MS 16 times 9. Which is MS what? 4, 35. 144. 100 and what? 44. Sasa zingine unakuja kuwa una calculate vizuri. Sawa sawa?
Yes.
So we get 36, 40, 144. Master that because I'm rubbing. 36, 40, 144. Can you sing that?
36, 40, 144.
Again?
36, 40, 144.
So we are getting the LCM of 36, 40, and 144. And avoid saying 144. It's wrong to say 144. What does 144 mean?
1.
It means this is 144. These are how many 44s are here?
1.
So this is 144. So if you want to say properly, what do you say?
144.
But not saying 144. So we find the LCM. We start with the smallest prime number, which is 2. 2 goes into 36 how many times? 18. 2 goes into 40. 20. 2 goes into 144.
72.
2 goes into 18.
9.
2 goes into 20.
10.
2 goes into 72 how many times?
36.
2 goes into 10 how many times? It cannot go into 9.
Yes.
5.
18.
Then 2 goes into, no, it can't go into 9. It cannot go into 5.
9.
You know why we are saying it cannot go to this?
Yes.
These are odd numbers and they are not divisible by 2, right?
Yes.
Now we look again, now 2 is over. We cannot divide by 2 again. The smallest prime number that can divide this is 3. 3 gives us what? 3 by 5. It cannot. Then 3. The smallest number again is 3. 1, 5, 1. Then 5. You get what? 1. So the LCM is 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4. Times 3 times 3 times 5. So be careful here. Some candidates will fail here. 2 times 2, 4. 2 times 2, 4. 3 times 3, 9. 10 times 3. We have shortened them, isn't it? 16 times 5. Very good.
Times 5. There, 3.
Oh yeah, times 5.
Yes.
Here was 9 and then times 5. Yeah, you are keen. Clap for yourself once. Good girls. So if you are boy, you are something. So we get 16 times 45. 16 times what? 45. 45 times 16. We go 0. Carry 3, 27, 5, 4. Isn't it?
Yes.
Yeah, we get what?
0,
2,
2,
7.
7.
We get 720, not 720.
720.
If you say 720, you mean 20, 20, 20, 20, 20, 20. 1, 2, 3, 4, 5, 6, 7. These are 720. So, yeah, so you say 720 is the LCM. Number 8. Number 8.
Which one of the following statements is correct?
Yes, mwalimu atawafanyia hiyo. Yes.
Yes.
So your answer which statement is what? Correct, huh? So for the statements, for you to work them out, it is simple. Either change them into decimals, all of them, and then you convert the decimals, or you change the decimals into fractions and you convert them, right?
Yes.
So which way do you want us to go? We change them into fractions. So if we change them into a fraction, option A, we shall whereby we have 0.27 compared to, we are told it is what? Greater than what? 3/11. This one as a fraction it will be what? 27/100 compared to
3/11. Yes.
So when you compare these fractions, it is simple. 27/100 and 3/11. Which one is greater? We can use the LCM or we use the percentage. Right? So if we use the percentage, this will be the same as what? 27/100 times the total percentage upon 100%. This one will be what? 3 over 11 times 100%. Right? We are converting using the percentage. This will be the same as what? 1. This will be what? 27%. And this one will be the same as what? 300 over 11. Right? Whereby we shall go for long division. 311. Sawa? Then 11 to 3. 11 to 3.
Oh no, it can't.
Make it to become a 2 digits.
Number.
11 to that.
2.
Twice, which will give you
22.
2. Minus to get
8.
8. You drop 0.
7.
Take 7, which is
77.
77. Minus to get
3.
3. Take a decimal point and add a 0. You take
2.
2, which is
22.
22. This will give you what?
8.
8. You take you add a 0 because you have taken a decimal point again. You take 7, which will give you what?
77.
0. How many? 3. Two decimal places. So we compare 27 and what? 27.27 or to one decimal place, the one is 27.3. So when you compare 27% and 27.3, which one is greater? 27.3, isn't it? So is the statement correct that 0.27 is greater than 3 over 11? Is it correct? No. Move to the next one, where we have 0.27 is equal, the same statement. Are you seeing the same statement?
Yes.
Whereby, when you compare, are they equal?
No.
They are not equal, isn't it?
Yes.
Because moja ni kubwa na ingine ni ndogo.
No.
Then let us look at C. 3 over 11, which is giving us 27.27, is greater than 0.27.
Yes.
It is correct, isn't it? Yes. Then that one is less than. No. It is 0.27. That is less than what? 3 over 11? 11. So you can use percentage or you use what? The LCM. You compare using the LCM. So.
Banana clap of the teacher. Very good. So, yes, for charging. So we now, before we move to the next one, the KCPE setters, they are very fond of bringing these two fractions here, dash and 0.3. And they also fond of bringing a 9 and 0.9. And I hope they are not hearing 0.1. They are not hearing this so that they will change it. They like bringing this. Take care. This year they might bring this. Or another year. Are we together? So are that compared to 0.3? Why do they like bringing it? Because if I change this to a decimal, I change it to a what?
Decimal.
We divide 3. This is the divisor by 1. Isn't it? How many times? 0. We add our 1 there. It becomes 3 because of 9. Some candidates will just say now, oh, 0.3 equals to 0.3. Have we finished the sum? No. So we get 1, isn't it? We subtract. 10 minus 9 is 1, isn't it? We have to put a 0 and then divide again. 3 by 10? 3. So it will keep on repeating. So our answer is 0.33, which keeps on repeating. We can write into 2 decimals, isn't it? Compared to what I had written here, 0.3. So now to compare them properly, this one I put 2 decimals. So this one I put another decimal. So what decimal do I put here? 0. So you are comparing 33 with 30. 33 with what? 30. So which one is which? What do I say about 33 and 30? 33 over 100 and 30 over 100. 33 is what? Greater. 33 is what? Greater. How do we put the sign greater than? That's also another challenge for some candidates. Yes, this girl is showing me I do this. I do what? This. And then, oh, I can do this. But if you don't remember whether to do this or this, what should remind you? Yes. Let's see. There is one way which you can never forget.
Yes.
Let's see. That's where we have fun of mathematics now. You have forgotten whether you do this or this. In the exam, you are trying to do this. You do this. Which one? You repeat again this. You are confused. So which one will not confuse you?
face the greater number.
You face the greater number.
Then
You open your mouth very widely to swallow it. You see the way he has opened the mouth?
Yes.
Then we draw that wide open mouth to swallow that big number. Right? Yes, to swallow. Can you clap for that boy? That's very good. So this side is what we call greater than. So when you find yourself, you are confusing which is which. Just like 9 and 15. Now, come and open your mouth to swallow the big number. Because we know 15 is greater. So you turn and face the big number. Simama katikati ya namba zote mbili. Sasa angalia namba ile kubwa. Stand in between them. Yeah, face the numbers. Face them like this. Look at me, just follow me. Look, face the big number. Turn and face the big number. No.
The big number.
You are facing 9. No, just stand the way you are standing. Just stand the way you are standing. She's facing what? The small number. Follow my instructions. Look at this. This, I'm standing here first, right? The big number is 15. So I will turn and face the big number. Why are you turning and facing the small number? Turn and face the big number. Don't lean on the blackboard. Yes. Open your mouth widely to swallow it. Good. Then you draw the side, the opened mouth. Are we together? Yes. So let's test her again because it's like she has not understood. This is 1,000 and this is 10. Stand in between them, first facing them like this. Just look at what I'm doing, yes? I face the big number. Face the big number. You are in between the numbers. You are not outside. In between. My friend, stop and listen. Listen, Esther. Look at me. Look at me. Just stop doing anything. You stand in between the numbers like this. Looking at them like this, right? This is the big number. I turn and face the big number. Right? Like that. So stand in between them. Stand in between them. Yes. Are you between them?
Yes.
Face the big number. Ukiwa katikati, umetoka kando. Yes. Open your mouth. Good. Swallow the big number. Clap for her. Very good. So, because when you do this and you do this, sometimes you confuse which is which. So, you can use both method, whichever is comfortable for you. Are we together? Yeah. We go to number 9. A very sweet question. I love these questions. I wanted to hear, so do I. You don't love them?
Oh, so do I.
Do you love them?
Yes.
We have pyramids and we have what? Prisms. I want to differentiate the two. To differentiate what? The two. Pyramids and prisms. Pyramids and what? Prisms. And my friend has brought me one of them. One of them is here. Another one is here. Another one is here. Another one is where? Another one is here. Yeah, we look at these things. Another one is here. Can you see? We are talking about these things. I wish we could have the other one. The one which is mostly tested in KCPE all the time. There's another one somewhere. Yes. Yeah. But just leave it, we shall draw it here. So, we want to see the difference between pyramids and prisms. Looking at this, very good. Looking at this. One, look at this one. When I hold this one, these are called the V's, the corners, the vertices. The what?
The vertices.
Let's count the vertices, the V's. 1, 2, 3, 4, 5, 6, 7, 8. There are 7 V's or vertices, isn't it? 8 V's or vertices, right?
Yes.
Now, when you look on the upper side, the upper what?
Side.
There are how many? 1, 2, 3, 4. There are 4, isn't it?
Yes.
On the upper side, eh?
Yes.
When you look at this one, on the upper side, how many are there? 1, isn't it?
Yes.
When you look at this one, on the upper one, the upper part, how many? 1. When you look at this one, it has how many vertices at the top?
2.
That's one way of differentiating pyramids and prisms. How? Any which has more than 1 on the upper side is a prism. Is that what? The one which has got only 1 vertex at the top, which has what?
Only one vertex.
The singular form of vertex is vertex, which has got one vertex at top. At what?
Top.
At the top. That is a pyramid. That is a what?
A pyramid.
And then prisms have more than one vertex. They have more than one vertex at the top. At the what?
The top.
At the top. Right? So holding this, tell me, is it a pyramid or a prism?
A pyramid.
How did you know that it's a pyramid?
Just
One vertex. They resemble those which were built in Egypt. Thousands, or I don't know a lot of social, but I know they were built. Is it thousands or millions of years ago?
Billions.
Millions, eh?
Yes.
I doubt you are asking your social. They were built long time ago. They had only one vertex at the top, right?
Yes.
Yes, so they had only one vertex at the top. And that is research. I will ask tomorrow whether you remember. Is this a pyramid or a prism?
A pyramid.
So is this a pyramid or a prism?
A prism.
Why did you call it a prism?
It has more than
It has more than one vertex at the top.
At the top.
Well, so what can I call this?
A prism.
A prism, because it has more than one vertex at the top.
At the top.
So we are able to group them into prisms and pyramids. Prisms and pyramids.
Pyramids.
Are we together?
Yes.
Then the other thing, after identifying that, the name we give them depends on the shape. Depends on the what? Like when I hold this, you have told me this is a pyramid. You look at the bottom. You look at the what? The bottom. You look at the bottom. What shape is here at the bottom?
Square.
A square. This is a what?
A square.
So I can comfortably call this one a
Square
based pyramid. What made me to call it a pyramid? It has only one vertex at the top. Look at this one. Look at the base. It's a triangle, isn't it? So what name will I call it? A triangular based pyramid. Why did we call it a pyramid? It has only one vertex at the top. At the top. So we are done with that. Are we together?
Yeah.
Then we come to that. The most tested in KCPE. The most tested in what?
KCPE.
Because you are about to tell me what? A rectangular, let's go.
A rectangular
Based prism. That's what you are about to open your mouth and tell me, isn't it? But I will say no. I will say what? No. Why is it not a rectangular based prism? It's a prism, first of all, right?
Yeah.
We can't place it here in pyramids. It has more than one vertex at the top, isn't it?
Yes.
So what will determine its name? It is something we call the base area. It is something we call the what? The base area. Something we call the what?
The
base
base
area.
area.
Base area is that shape which is opposite another one and they are exactly the same. Are we together?
Yes.
Like this shape and this shape are opposite each other and they are exactly the same. Are we together? In a content, in a figure, we look at two shapes which are opposite each other and are exactly the same. One of them we call it the base area, the cross-sectional area. The cross-sectional area. Like if you were to get volume, you would get the base area times height. The base area times height. Cross-sectional area times length. Let's go. Base area times height or cross-sectional area times length. So this is now the base area. So this is where the name lies. This is where the name lies. So what name do I give it? A triangular. Yes, a triangular based. Can you see the word based? Based. Based prism. A triangular based what? Prism. A triangular based what? Prism. So if I turn it like this to face like this is the bottom and this is the base. The triangular based prism. The triangular based what? Prism. Whose other name is the wedge. The what?
wedge.
Now let's look at that. I've placed it. So what is at the bottom here?
Square.
Is it a square really?
Yes.
A square? I don't want to call it a square because not all sides are the same.
Yes.
So this will be a rectangular based It will be a rectangular based what?
Prism.
What name will I call it? Rectangular based prism. Rectangular based what?
Prism.
Because this and this are the same, isn't it? So I will draw for you a square based one, how it looks like. A rectangular, a what?
A rectangular
Based prism. Remember, it's a prism. Why is it a prism? The top has more than one vertex. Are we together? So it's rectangular based, or if I hold it like that, you can see still a rectangular based prism. A rectangular based prism. The one we call a cuboid. The one we call a what? Cuboid. That's why I was insisting it's not a square based. Because if it was a square based, it would be totally a cube. It will be totally a what? Cube. So you can't call this a square based prism. Are we together?
Yes.
Because some of the lines are not the same. So this is a rectangular based prism, which is a cuboid. Which is a what? Cuboid. So now after this, I think we are together now, right? It comes to how to draw them. How to do what? Draw them. If I want to draw them, looking for my desk. If I want to draw, for example, this one I'm holding. This one I'm what?
Holding.
I can rub here now, your feet?
Yeah.
Okay, I want to draw this pyramid I'm holding here. I just need to draw its base. Just that. I just need to draw what? Its base. Its base is this. That's its base, isn't it? And then I put a dot which represents the vertex at the top. This dot, right?
Yes.
Then after I finish that, I join all the points of intersection like this. So sweet. So what? And I form my what? I form my square based pyramid. Why are we calling it a pyramid? Because of one vertex. Then from here, I'm able to count the edges, which are also called lines, and I'm also able to call the vertices. I'm also able to count the what? The vertices. I'm looking for the other pen.
Wow.
Like this.
This one,
Oh yeah. That's what I'm looking for. So the square pyramid. So from here, what can I count? The edges and the vertices. Let's start with the edges, the lines, right? 1, 2, 3, 4. And remember, this goes up to the bottom. See, then 5, 6, 7, 8. How many edges? 8. Let's count the V's. 1, 2, 3, 4, 5. How many vertices? 5. If I want to count the faces, repeat my statement.
If I want to count the faces,
I will not count it here, because here you can confuse yourself and find yourself repeating some. Are you together?
Yes.
To count the faces, I will not use the solid. This is called the solid. I will use the net. I will use the what?
the net.
So how does the net look like of this? I first draw the square. I draw the what?
The
Square. I draw the square. Is that square clear? Then I draw these triangles. I draw the what?
The
Triangles which were joined. That triangle, this triangle, and this triangle. Remember what? Remember what? Remember this line, and this line, this should be the same. Why should they be the same? Because they will be formed to join at one vertex. So if this is 10, this should be 10, 10, 10, 10, 10, 10, 10, 10, 10, 10. Are we together? Yes? There's a time they tested that. So from here, I'll be able to count the faces. Let's count the faces. 1, 2, 3, 4, 5. I comfortably say what? 5. That's how.
Yes.
Hello?
Hello.
Then, there is a formula which proves that you are right. Wow. There is a formula that proves you are right. Can I say the formula?
Yeah.
The formula says, says, faces in any shape plus vertices. Can you say that?
Faces in any shape plus vertices
Equals to edges minus 2.
equals to edges minus
Faces plus vertices.
Faces plus vertices.
It's like you're afraid of saying that. Faces plus vertices
Faces plus vertices
equals to edges minus 2.
equals to edges.
What was the number of faces in this question?
5.
What was the number of vertices?
5.
What was the number of edges?
8.
8. No, plus. Yeah, their edges were.
Yes, the edges were 8, but you're saying 5 plus 5 is 10, not 8.
Yeah, nisema hapa the formula yangu hapa ni plus 2. Ni plus what? 2. Sorry for the mistake. Hebu twende tena. Faces plus vertices equals to edges plus 2. Let's continue.
Faces plus
vertices equals to edges plus 2. So edges ni 8 and we add 2. Let's see whether the statement is correct. Is the statement correct?
Yes.
Anything that I will draw here, tell me to the last thing to do to prove this formula whether it's right. Are we together?
Yes.
We move to another one. We move to another one. We come to this one, which is mostly
what?
So we draw the prism. We draw the what?
The
Prism. We draw the what?
The
prism. So this triangular prism. Why did I call it triangular prism? Because of the base. Because of the what?
Base.
The base. And I want you to look at what I'm doing and you also try to draw that. To draw what?
First.
Do you remember how I drew this?
Yes.
I just drew a square and I put a dot here, then I joined the vertices. Are we together? Then for this one, get your book and try to do what I'm doing. It looks very complicated for those who don't know how to draw, but I'm going to take a very short time to draw it and you'll just love it. You just love it. Are we together?
Yes.
Are you set?
Yes.
Draw a triangle, just a small triangle, like that. Like what?
That.
Don't use a ruler. Use your free hand like me. Good. Don't draw tiny things like yes. Yes. Draw using your free hand, right?
Yes.
Then here. Don't draw, listen first. Listening is a virtue. Here, below this triangle, somewhere here below, here. There. Right? Not here on the same level, no. Just somewhere here below. Draw another triangle of the same size. The same what? Size. Just below. Space them, right? The same size, eh? The same size. Yes. Mwalimu niangalie kama amechora hiyo. Then you join the top vertex with this top vertex there. Join this vertex with this farthest vertex here. Just with your free hand. Usitumie ruler, free hand. Free hand. Why are you rubbing? Then join this vertex with this other vertex here. Like that. Don't you have this thing? Wow. Don't you have it? You have it, isn't it? Try drawing the first one looking like a right-angled triangle. Then the other one also like a right-angled triangle. Then you join the vertex again. You join the vertex again. Like that. To be able to get that shape very quickly. Just drawing a triangle and another triangle there. Are we able to do that? Wasaidi hawa wanakwama hapa. I repeat again, a triangle and the triangle below here.
Wow.
Just, I've drawn 5 so far. When you are drawing one, how many have you drawn so far? 2. We are just practicing. Have you been able to draw that?
Yes.
Good. Then from that of this, I said we can get 2 things. What 2 things can I get? Faces and vertices. Isn't it? Edges and what? Vertices. I said faces, don't count them here. Edges, let's count the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9, isn't it?
Yeah.
Vertices. V's. 1, 2, 3, 4, 5, 6. How many V's are there? 6. Faces. I have to draw the net. This was the solid. The net. So what is the net made up of? There are 3 rectangles. 1, 2, 3. Those are 3 what? Rectangles. I put the 3 rectangles together. Like this. 3 like that. Are we together? Those 3 rectangles, I put them together. So I put them together like that. I put them like that. Then after I put them together, the real rectangles, I put the triangle here and here. The triangle here and where? Here. Are we together? Then after I do that, before I mentioned, I told you this line should be the same. All those lines should be the same, because when you join, you want them to join and meet at one vertex. Are you together?
Yeah.
So all these lines should be the same, but these are different. This one and this one, this is equal to this and this is equal to that. Are you together? But easy equal together. Are you together?
Yeah.
Then from here I can count the faces. Let's count the faces. 1, 2, 3, 4, 5. How many faces are those?
5.
I said every question I end with what? Faces plus vertices equals to edges plus 2. Can we repeat? Faces plus vertices equals to edges plus 2. Let's see whether it's true. 5 plus 6 equals to 9 plus 2. 5 plus 6, 11. 9 plus 2, 11. This is something to confirm whether you are accurate. If it doesn't come to that, then know somewhere you have gone wrong in the counting, and then you check again. Are you together?
Yes.
But ours is perfect. Ours is what? Perfect. So we can end our lesson there, and I'm glad that you are we are together. To the next lesson, we shall continue with from where we have reached. Bye. Asante.